It is my great pleasure to introduce our keynote speaker, Jeff St. Clair. He has reported on science in Northeast Ohio since joining the WKSU Public Radio newsroom 15 years ago. Prior to that, he was a music host and fund drive producer at WKSU. And before that, Jeff spent 13 years as an analytical chemist in Akron and Canton. Jeff graduated with a degree in chemistry in 1987 and completed his master's in journalism in 2012. He says he's always wanted to be a scientist, but got distracted along the way. As a science reporter, he loves visiting people's labs and documenting the work of hundreds of researchers in his Explorer radio series at WKSU. He says it's a privilege to meet so many amazing scientists in Northeast Ohio and bring their work to the public. His favorite topics include evolutionary biology, human origins, neuroscience, human behavior and political psychology, biological diversity, bats, bugs, botany, and the origin of the universe. So you could see he loves all things nature. Jeff enjoys the challenges of translating complex scientific research into everyday language that thrills and informs his listeners and readers. He's been heard nationally on NPR and Marketplace and every weekday from noon to 4 at 89.7 WKSU. In his spare time, he enjoys hiking, kayaking, guitar playing, fossil collecting, and observing every living thing in the natural world. So let's give him a hand and welcome our keynote speaker, Jeff St. Clair.
Thank you, Catherine. Appreciate that. Thank you all for sticking around. I know you've, had your, brains kind of filled with all these amazing presentations, and I am so honored to be here, to be speaking, and also be a judge in this competition. So at this point, you guys are all off the hook. If you fall asleep, that's fine, just because they gave me 10 minutes, and I don't see any stop clock, so I might just keep going. But we have a sign in front of our house, and it says, "Science is real." We believe science is real. It also says, "Women's rights are human rights. Black lives matter. No person is illegal. Love is love. And diversity makes us stronger." These are all equally true, yet aspirational statements. The sign's been there for a couple of years. Science is real. At that time, it needed to be said. Research-grounded responses to the COVID crisis were superseded by rumor-based and politically driven nonsense. If science isn't real, what is? Our tenuous hold on reality quickly unravels if we question the system we use to describe it. Science is not just real, it is the ground we walk on. Nearly everything in our modern lives is based on science. Certainly our technology, cell phones, cars, healthcare, data-driven decision-making in all fields from government to Wall Street, all modeled on the scientific method. When we make decisions, we ask, what do the numbers say? When we confront new diseases, dilemmas, disasters, and other challenges, we turn to science to determine the path forward, from charting weather to modeling toxic plumes. When a child asks, "Why is the sky blue?" do we say, well, the gods prefer it that way. They like the color blue, and when Jupiter wanted to calm his brother Neptune, no, okay. That makes for a good bedtime story. But as a culture, we have changed our narrative. We say, it's because atoms in the air bend light waves, and since blue is the shortest wavelength, it bends the most, right? Or you tell your kid, no, just go ask ChatGPT. I admit we have lost a lot of the beauty and poetry of life after mythology took a backseat to the rational mind. But our path follows the steamroller of logic, linked to deliberate experimentation within a community of inquiry. That's science. It has radically remade the way we live our lives compared to the thousands of generations that came before us. And that's why when people in power question science, our reality is rattled. My science is real sign reminds us that science must not be subverted. It reminds us of the need to better explain relevant research. It reminds us that you need to be better communicators about what you do. It reminds us that there is a huge gap between the physical reality of our world and our comprehension of how it works. I call it the understanding gap. As a science reporter, my goal has to fill the understanding gap incrementally by looking at research and innovation. And as an aside, I was told early on that research is turning money into knowledge. Innovation is turning knowledge into money, right? Two sides of the same coin. I don't think we should judge the value of research by its immediate practical applications, though. That's a very narrow and dangerous limitation on the beauty of scientific inquiry. The understanding gap, though, is growing exponentially, and we are at risk of falling forever behind. I think about my grandfather. He was born in 1910. He died in 2003. During his lifetime, he saw the first airplanes, the first cars, the first telephones, TV, nuclear weapons, computers, and digital technology. He was born with horse and buggies, and in his lifetime, saw a man walk on the moon. Has that pace of innovation changed? Do you really think? If we were to look at a chart, I do not think it has changed. It's not likely. People don't turn back the clock of innovation. Consider our headfirst plunge into the all-encompassing digital reality and the birth of AI. It's obvious we are in over our heads. It might be helpful to look at how we got here. This is where the nap time comes in, but I think it's important to take a look at the roots of our shared passion. Science began 400 years ago with Galileo. It was in 1623, exactly 400 years ago, he published Il Saggiatore, the Assayer, the book where he laid out the scientific method and famously wrote that math is the language of science. 10 years later, Galileo was convicted of suspicion of heresy and placed in house arrest for the rest of his life for suggesting the earth orbits the sun and not the other way around. No one in Florence put up a sign that said science is real, even though Galileo was taken away to jail. Nonetheless, science became real. Soon, Descartes developed the language of algebra. Kepler and Copernicus described the laws of planetary motion. Robert Boyle laid the foundations for modern chemistry. Newton and Leibniz developed calculus. The laws of thermodynamics powered the Industrial Revolution. Maxwell wrote his famous equations. Darwin, Pasteur looked at living systems. Einstein explained the universe. Modern science, with roots going back to the Greek philosophers, had bloomed out of the fertile mud of medieval conjecture and alchemy. Knowledge and innovation grew by adhering to the scientific framework. Your work builds on the incremental achievements of scientists going back 400 years. This is the world you have inherited and the world you need to defend. Because for political or other reasons, people continue to cast doubt that science is real. Take evolution, for example, the foundational principle of biology. Living things change over time. Darwin credited natural selection and sexual selection. Species change over time, not that big a deal. Yet plenty of people question the validity of the theory of evolution because it acknowledges that humans and chimpanzees have a common ancestor. I say get over it. You benefit from science every day. I'm talking to the people, and maybe not anyone in this room, but there are people who question evolution. You take antibiotics, you have a cell phone, you have a laptop, LED light bulbs, but you say this one branch of science is unreal? You don't get to pick and choose what parts of science are real or not. Except if you're Amish, and then okay, because then you're not using it anyways. But people who have watched the COVID virus mutate and evolve in real time, they still say, evolution, no, it's just a theory. This is obviously a pet peeve of mine. And they gave me an axe to grind. I'm going to grind it. More than a dozen states allow creationism to be taught alongside evolution in public schools. At least 3 states do not make evolution part of the curriculum. It's like teaching flat earth theories in geography class or the 4 humors in health class. Everybody remembers the 4 humors, right? Blood, phlegm, anybody? Black bile and yellow bile. You guys are smart. It's funny, you know that stuff. But this is one reason science does need defending. The both sides argument surrounding evolution eats away at the legitimacy of all research. Science is real, but it can be lost if we let it. A return to the medieval world of humors and quackery is just one zombie apocalypse away. This is ostensibly why I was invited here to talk, to help you guys talk about your work and help us bridge the understanding gap. I had to get the evolution stuff off my chest. So, the challenge of science communication is really rooted in the origins of science itself. Because while math is the language of science, very few people speak it, myself included. It makes it hard to talk about it. So we need to translate our work. Stephen Hawking, talking about his book, A Brief History of Time, which is an awesome book, only 180 pages. It's a must-read. You guys read it. Read that book. If you haven't, it will change your life. Brief History of Time, Stephen Hawking. Hawking said that he was told for every equation in his book, he would lose half his readers. So only you put one equation in the book, E equals mc squared. And this is from one of the greatest mathematicians of our time. So in order to talk about your work, you need to rely on language. And we know how muddy that can be. You need to understand the relevance your work has to the broader world. And I heard a lot of that today. And you need to find the everyday non-technical words to express it. That's the whole point of the 3MT competition. And I think you guys nailed it. All that said, not all research will be immediately relevant to today's public discourse, and that's okay. You didn't go into science to be famous, I'm guessing. You went into science because you have the chance to learn something that no one has ever known before. There is no thrill like the thrill of discovery. We have an obligation to fill the understanding gap before the AI bots take over and we devolve into subhumans, or at least a population of science deniers. Scientific language, by necessity, is precise and specific. But much of the meaning can be lost when you dip into vernacular. Therefore, you need to borrow the poetic tools of analogy and metaphor. Analogies are tricky. Before Galileo, there was alchemy, which is driven by analogy. Alchemists believe matter is composed of 4 elements: earth, water, fire, air. And apart from serving as the basis for the excellent Avatar cartoon series, if anyone has seen that, here we got a fan. Those elements, I'm not even going to go into it, because we know alchemy is a dead end. And that is one reason scientists avoid analogies like the plague. Because in order to distinguish yourself from alchemists, the first scientists avoided analogies. Nevertheless, I will go into how you might use them. There are a few simple rules. Number 1, be clear. Ernest Rutherford, the father of nuclear physics, when describing his model of the atom, said it's like the solar system. Big object in the middle, the nucleus, lots of little things surrounding it, orbiting it, electrons. He was the first to describe it that way, and it went against the current thinking. But after he explained it, everyone went, oh, yeah, that makes sense. Except for the group that had convicted Galileo, and they were confused by the analogy, right? Robert Hooke was the first person to look through a microscope and see a cell. He called it a cell because it looked like a little room. Boom! We all know what a cell is. Analogies need to be based on what the data shows. Kepler hated analogies, but he still used them to explain his work. In one treatise he wrote, "Analogy shows and geometry confirms." That distinction is what makes his and your work science rather than alchemy. Analogy helps explain your research, but we all acknowledge that there is no causal implications in a metaphorical comparison. Finally, choose wisely. Metaphors are powerful. Humans have evolved to think in metaphors. We are not computers, despite the wealth of analogies between the human brain and machines. According to narrative theory, we think best in terms of a coherent story. That's why Jesus spoke in parables. We are a story-hungry species. They've kept us alive over millions of long, cold nights. All you need is the kernel of a story. See where it takes you while remaining grounded in fact. The public may not know the technical explanation for many common phenomena, but they recognize the shorthand versions. Black hole, food chain, climate change, dark matter, Big Bang, standard model, heat sink, missing link, fission, fusion, feedback loop. We get it, sort of. There is a saying that the next scientific revolution starts when the analogies run out. When we can no longer convey what we're doing using simple language, it means that we have reached the limit of our knowledge. Maybe there is a vital interplay between scientific discoveries and public understanding, after all. Maybe filling the understanding gap is not just vital for the public to comprehend our rapidly changing world. Maybe it's important for scientists to take the step of communicating their work and thereby explore where those analogies might take them. Many believe that science is separate from the common world, that it exists in the rarefied realm of academia and is only passingly relevant to the chaos of daily life. But that assumption is wrong. Science is real. And we need to keep it real. The rational mind remains the greatest human invention. But it is up to science to show how the reality it created can be made sustainable. And I think that's what the sign means in front of my house. That's it. Thank you.